Hello everyone, welcome to my YouTube channel. So today we'll be looking into a very important Java concept, that is use of this and super. Use of this and super. So we may divide this session into two. Part 1 we'll discuss on this and second one super. So first of all, let's see this. So the first point of this is it is a reserved keyword. It is a reserved keyword. That means we cannot use it as an identifier. Second, it refers to it refers to current class instance, or you can say implicit reference variable. So what is this thing? First point is saying it is a reserved keyword. This is a reserved keyword and we cannot use it as an identifier. That means you cannot write int this integer variable. This, suppose just like int a is an identifier, you cannot use this. It is having the specific purpose and where to use it. Okay. And second thing is refers to current class instance. What do you mean by current class instance? Okay, let's say I'm having a class A. If I want to create an instance of A is equal to new A. What do you mean by that? It is an object. Here, A is reference variable, or you can say object, but we should say reference variable, or pointing to object, we can say pointing to object of A, right? And also it is explicit, we can say explicit reference variable. Why? Because user has explicitly created this reference variable. But this we don't need to create by any new keyword, something else like that. This is implicit reference variable. That means it refers to current class. That means the class in which this is used. If I use here this inside A, automatically it points to the object of A. That means if I show you the diagrammatically, that means if we are having a is equal to new A. Suppose you are creating the object A and here A is a reference variable and which is referring to A. Similarly, this is also kind of same. This is also a reference variable but which is implicit. User is not creating this. Okay. It is also pointing to the object, right? And it is implicit. User has not created. It refers to current class in same reference variable, that is the class in which this is used, that is called current class. The class in which this is used, it corresponds to that class implicit reference variable. Okay, so where at which places this can be applied, which cases this can be applied, which cases this can be applied means which scenario, let I'll put in double quote, can be applied. So first point, first one is we can say to refer instance variable of current class, to refer to instance variables of current class. Two, what is two is saying? To call current class current class constructor. 3 can be passed as an argument in a method call. Similarly, can be passed an argument in constructor call, and the final one is can be returned from current class, can be returned as current class instance. Okay, you can say, sir, can be passed as argument to method call, then can be passed as argument to constructor call, that means method constructor, same thing, means sorry, same situations. Okay, passed as an argument to a method, passed an argument to a constructor. Then similarly can be written as current class instance from a method. We can write, can we write can be returned as current class instance from a constructor? No, because constructor is not having any return type. Okay, so restrictions. What are the restrictions? First, it cannot be used in static areas. Static area means what? Static block and static methods. We cannot use this keyword inside any static block or static method. This is one restriction. Second, acha, so this is a keyword, right? So how can we distinguish between a method call and a variable call and a constructor call? Simple thing to illustrate. For a constructor, you have to write just this, or it can be argument, right? That means this refers to constructor. And for variables, this dot variable name, and for methods, this dot method name with signature. What is the argument to be passed? What is the argument to be passed? That means this dot variable method name for accessing the variables and methods, and then this within parenthesis with parenthesis, it is for constructor call. It is for constructor call. Okay, it can also have argument if you are calling parameterized constructor. Restriction is, we'll see that in programmatically, if it is used to call constructor from another constructor, it must be the fast line inside the constructor. We'll see that how it will work. Okay, so this is the places where this can be used. We'll see one by one with examples, and this is the restrictions, and we'll see everything programmatically, and during the program illustration we'll get more concepts and we'll discuss more on this. Okay, let's choose the first one, to refer the instance variable of the current class. Okay, let's see. Class, this test I am taking, this test, this test. Okay, then let me save it. Let me save it. So it is this test dot java. Let me declare some instance variables, private int a, private int b. Okay, I want to initialize by the help of the default construct that I am writing, a equal to 10 and b equal to 20. Right, now I want to print it public void display. system dot out dot println this dot a. I told you here. Now this dot variable name, this variable is instance variable. This variable is instance variable. So this dot a, then this dot b, this dot b, right? Let's write our main function, public static void main string args. Then I will create the object. This test equal to new this test dot display. Let's say, let's see how the program will execute. This test dot java, then now 1020, right? You can now say, sir, without writing this also, it is 1020, right? Yes, 10. No, what is the why we are writing this here? Now here in this scenario, writing this is same as without writing this as well, because it will automatically take as current class instance this dot a and this dot b. But I will show you another example where you will be required to write this. Here it doesn't matter. Even though you write this dot a, this dot b, that doesn't matter. Okay. Now let's take me parameterize variable int x, parameterize constructors. A equal to x, b equal to y. As I'm using now parameterize constructor, I need to supply two values here, 10 comma 20 display. Now let's see. 10 20. What is the difference then? Okay. Let's say these variables are a and b. Obviously there is no x, no y. Now let's see what output will be getting. Ayo, it is 0 0. How? How that is 0 0? This is my instance variable, and these are the argument variables. You can say as local. They are equal to a, b equal to b. How this is happening and how it is printing 0 0 even though I'm passing 10 20? Okay. So in this situation, actually, there is a confusion for the JVM that which one is instance, which one is argument variable, right? So whenever you create the object by new keyword, memory is allocated and A or B are by default assigned to 0. Then this constructor is invoked. It is passing 10, 20, but there is a confusion that which is instance, which is local. So the variables are properly not initialized. It is called as shadowing. Local variable is here overtakes or dominant the instance variable. But we can say in the program, means as a programmer, we can say the left side is instance variable, right side is the argument variable, right? Same here also. But there is a confusion for JVM because this variable dominates inside this constructor. So now I need to help JVM to understand that boss, this A is instance and this A is argument variable, right? So for in this case, it can be solved by using this dot A and this dot B. Now, when the execution will happen, JVM can know that this is always associated with instance variable because you have written here this dot variable name is always instance variable. So undoubtedly left side is the instance, this A and B, and the argument variables are this A and B. So now we'll see the output, whatever we are claiming Is that correct or not? See, now this is a equal to 10, b equal to 20. That means when this for instance variable is useful, now whenever we are initializing the variables by means of constructors or by means of methods, and we have the argument variable name and instance variable names are same, we have to associate this with this variable name, instance variable name. Then there will be no shadowing, no confusion between the instance variable and local variable. Values are properly assigned. So this is the example of how to use this with instance variable. But if these variables are same, sorry, not same, it is x and it is y, you need not try to this. Not required. It is not required. Okay. So now we have seen the first to refer to instance variable, the current class. Now the second is that to call the current class constructor. Okay. Same program I will modify. I will write now a default constructor. I will write now a default constructor. And I want to invoke this parameterized constructor from this default constructor. We can also do vice versa. Okay. So how to do that? I mentioned here. For this, you need to apply the parenthesis. Then it will treat as constructor. So now I will write this. Okay. But this no argument points to the same constructor. Same no argument constructor. Okay. So now we have to call this constructor, which is two argument, then pass here 10 and 20. Then pass here 10 and 20. That means this is always constructor. And this argument defines which kind of constructor you have the constructor overloading scenario. Then here one integer, which is matching. This one is matching. Okay. Now as we are calling from this constructor to this constructor, I should create the object with this constructor. Now we'll see. Let's put some SOP statement so that we can get to know what is happening. System.out.println. I can write here no arg constructor called. Okay, and I can write here to arg constructor called. To arg constructor called. Execute, compile. What is the output here? First to arg, then no arg, and then we are getting 10, 20. Now let's do the anatomy. We call this test equal to this test. It calls which constructor? Default constructor. And from the default constructor, we are calling at line number 11 two parameter. That means from here 11 control will immediately go to the this statement, which will assign the values. Past is a is 10, b is equal to 20, this dot equal to 10, this dot equal to 20. Then system dot out dot out. The first output is second arg constructor. Then after the execution control return to this part. Now the second no arg constructor is called. Okay, then we are calling display function, we are getting the output, right? And we mentioned one point here, if you remember. It can be, if it is used to call constructor from another constructor, it must be the first line inside, spelling mistake, inside the constructor. Now let's shuffle it. First this thing, second one is this thing. Call to this must be the first statement in the constructor. Call to this must be the first statement in the constructor. That means you cannot have this at anywhere position. It is having specific position defined. So you have to write this constructor here only. We have to write the constructor here only. That is this 10 comma 20. This will do that. Now there is a question, sir, you mentioned here can be to current class constructor. Acha, can we call the constructor from a method in the first line? Is that possible? Let's see. This call must be the first statement inside the constructor. Now see, when the constructor executes, the common simple question, when the object is created or constructor is invoked, right? But here, when you method will invoke, then constructor will be called, which is worthless because constructor is always created when this object is created. That means a constructor can be called inside another constructor only, and that must be the first line. Okay, now you understood the second part to call current class constructor. Now, I will show you a twist. This. That means what I'm doing here. From this test, I'm calling parameteric constructor, which is going to this test. And from this test, I'm calling default constructor. Again, it comes to this. What will happen for this kind of program? Have you heard about something called as the, what is that? Stack overflow error. That means it will be recursive, right? It will call this and it will call this. It will call this and again it will call this, right? Recursive kind of thing. Let's see how the compiler behaves for that. See, recursive constructor invocation. That means compiler will prevent you if you write this kind of recursive constructor call. It is not like the method, it will give rise to exception. The constructor will check whether there is a recursive call or not. That means if we try to do a recursive call, first thing is that compiler will stop us. Hey boss, you cannot proceed. Okay, so this is to call the current class constructor. So this is over. We explained it. This is over. We explained it. Now, can be passed as argument in a method call. Can be passed an argument, can return as a current class. Okay. To refer to instance variable or current class we completed, can be passed an as argument in a method call. Okay, I think I missed another thing. To call current class method you can say, but that is not so important, but we can see that. To call current class method. Okay, what do you mean by this? Public void display one, let it be. I want to call display inside display one, this dot display. But even though you don't write this, na, it will work. That is why it is not so important. Now you call display one. That means you call display one, call goes to here, and here this dot display call goes to here. Okay, now let's see how it behaves. Fine, output. But let's remove display. Let's remove display. Still it is giving me the same output. Still it is giving me the same output. That means here calling current class method inside another method using this is same as without using this. Okay, that means without this also it will work, right? So that's why it is not so important point in our discussion, but though we can have that. Next, that means it is current class method. We have covered this. Now, what is the third point? Can be passed as argument in a method call. Can be passed as argument in a method call. That means we can pass it inside an argument to a method. Let's see how we can do that. Okay, that means we can pass this as an argument. Okay, fine. Okay. Hmm, I can write a function here. I can modify this display function. I can modify what happened. I think one extra bracket is here. Okay. What? This display function, let's take object as argument. Same this test. This test, suppose this test, right? And I will use here this object this test dot a and this test dot b. That means public void display is now a parameterized function, and I have to pass here as argument is this test. That means same class object I am passing, and I am using here this test dot a, this test dot b. Now same, I'll get back the old function public void display one, right? Now from display one, I want to call the display function. Now I can call display this dot display or only display, that doesn't matter. Now this display function takes argument of which class object? It is object as argument, same class this test. Remember, same class. And for the same class, we know what we can use current class reference. This we pass just this. Let's see. Very nice. We're getting the output. Now let's see what we have done. We created the object by using default constructor as usual. It is calling the parameterized constructor. We have already discussed. Now most important is this display was earlier a default method. It's a no argument method or default method. I passed an argument. Which object I am passing? Let's see. Same class object, current class object I am passing, right? This test, this test. Then I am this test dot a, this test dot a. Okay. Now I am having another method display one. From display one, I want to call this display. Instead of this test object, right? What I passed here? Just this. Just this means current class object. Okay. Otherwise, I could have done like this. Create instance, this test, tt is equal to new, this test, and pass tt here because it needs current class object. So explicitly, I can call, create the object, and I can pass the value, right? Why two times it is executed? Because I'm again using constructor. But why I will do that? I know I am having a handy implicit reference, right? Why I will create another one and write extra line of code and constructor execution two times? Just pass this. See, executed, correct? Okay. See, important note here. Can be passed an argument in a method call. See this line I highlighted. Method call. That means whenever you are calling, don't think that you can pass while declaring a method. No, not at all. While declaring a method, you cannot call that illegal start of type, right? So read this statement here. Argument in a method call. Whenever you are calling a method and that method takes the current class object as parameter as argument, just pass this there. I think it is clear. Okay. Now, same thing but for a constructor. What is this? Can be passed as an argument in a constructor. Okay, we will see that. How we can pass. Okay, so now we cover can be passed an argument in a method call. Now we'll see can be passed an as argument by constructor call. That means we can pass to a constructor. So how is that possible? We'll see that. That means while calling a constructor, we can pass it as this. That means suppose a constructor A, Suppose you are calling this. Okay, we'll see that now. Let's say we have a class X, and then we have another class called as class Y. Inside X, I will use the dependency of Y. Okay, now I will have the constructor of X, and I want to initialize this Y. See, instance and argument both are Y. So this dot Y equal to Y. Simply, I'll have a function, and I will write here system dot out dot println. I can write here X constructor. Okay, let's save it as first save it Y dot Java. Okay, now class Y. Now inside Y, I will have constructor Y. See, first a class X, then a class Y is there. Inside X, Y is declared as instance variable. I want to initialize X, then by parameter Y. This dot Y equal to Y. This is X. Now inside Y constructor, I want to call this one. Then what I will do? X is equal to new X. What is the argument to X? It is not default. Parameter is construct, right? And which type? Y object. You are in which class? Y class. Current class reference. This. That's it. Now write public static void main, and it is string args. Okay. Now I will call Y equal to new Y. Now let's save it. Java C y.java. Sorry, I have missed. Oh, semicolon. Compiled, and if you'll see, we'll get the output as X. So here what happened? Now while calling a constructor means creating the object of X, it requires Y object. So we are inside Y class, directly we can pass this. Directly we can pass this. So this is what can be passed as like A is equal to new A. This can pass an argument in a constructor. The last one is can be returned as current class instance from a method. Okay, that means it will return. We can write like return this inside a method. Let's see. We can write here class uh, say what I class M, small, very small program. Okay, and let's save it as m.java. Okay, public void display. Simple thing I will write here system dot out dot println m. Now I will write a method public m get instance of m. Get instance of m. Okay, get instance of m. Then I will write a function public void call display. What do you mean by this? What is the return type of this method? Public m get m. That means whenever this method is called, it should return instance of m. That means object of m class. That is object of the same class that the object of the current class. Can I write here return this? Because it wants object of m class. We are in the current class. Can we return that? Return this. Now I want to call this. So call display but I need instance. I know I can call directly this dot display. Otherwise, I can call without also display. But I want to call this by using the instance of m, right? So what I can call here, get instance of m, which will return this. That means writing this dot display here is same as get instance of m, because instance of m returns this. Then as usual, to test my program, I need public static void main. Let's simple call it public static void main. Object is m. M is equal to new m. Now m dot call display. Let's see first how it behaves. Java C m dot Java compiled. This is the output. We are getting m here. That means this can be returned from a method. So now in this video, we see what is this operate means this keyword in Java, and what is this useful, and what are the different scenarios we can use this to refer instance variable of a class, to call current class constructor, to call current class method, can be passed as argument to a method call, can be passed as argument to a constructor call, can be returned as current class instance. I think we forget one thing. In the restriction part, we covered this thing. One is still remaining, but that should be very simple. Let's say I will have int a is equal to 20. I can write this dot a. I can write here system.out.println this dot a. Okay, because we are in the same class, current class. Let's see what is this saying. Can we read out? Non-static variable this cannot be a reference from a static context. That means this is always instance. Okay, and it is non-static. And as per the thumb rule, non-statics cannot be used inside static. They can be used only through object reference. That means inside static methods and static blocks as well. Static blocks as well. We cannot write this. We cannot write this. You'll get now the same error. Okay. So now I think we covered all the aspects of this, its usefulness and where to use it. Thanks everyone for watching my video. If you really like the video and the content and the explanation, you can subscribe, like and share. Thank you.